Hey guys, Miss Ganell could not be here today, so I'm going to start 9.1 for you, and then when she comes back on Monday, she will go ahead and finish it for you. Okay, let me go ahead and get this set up. Make sure you have the 9.1 note, so it should look like this. That way it'll make it a lot easier as you go through. I hope everything's going okay. If you guys are having trouble with anything, make sure you email me, and I will be back April 27th. When I come back, we're going to build rockets and do a couple other fun activities. Okay, so this is your first day of trigonometry. So the first thing we're going to cover are just the different parts of a right triangle. So first thing I want you to do is just draw a right triangle. Okay, so there are three different parts, or four different parts. Down here in this right hand corner, I'm going to draw a little theta. So this is my angle. And the three different parts that I'm going to label. I'm going to label the hypotenuse, adjacent, and then opposite. And we'll go over what each one means. Okay, so the three different sides, we have the hypotenuse, opposite, and adjacent side. The hypotenuse is always across from the right angle. Okay, so here's my right angle. Opposite of it or across from it is always going to be the hypotenuse. So now I'm down to two sides. So the opposite side is always across from the angle that you're using, so across from theta. So here's my theta. Opposite of it or across from it is the opposite side. The adjacent side is next to theta. And then the reference angle, this is our theta. And it's just the angle being used to evaluate the triangle. Okay, so the reference angle here we had theta, so this would be our reference angle, and that's just the angle that we're going to use to evaluate the different sides of the triangle. Okay, so a trig ratio is just a ratio that describes a relationship between the sides and angles of a triangle. Okay, so ratio, it's going to be a fraction, and we're going to use theta, opposite, adjacent, and hypotenuse for the three different ratios. Okay, the three ratios are ratios that you're going to have to memorize. Okay, so the first one is called sine. So we have sine of theta is equal to opposite. I'm going to abbreviate, so I'm just going to put OPP. So opposite over hypotenuse. So cosine of theta is the second one. This one is adjacent over hypotenuse. And the last one is tangent. So tangent of theta is opposite over adjacent. Okay, a way to remember them. So if we look at sine, let's just look at the first letter of each part. So sine, we have S. First letter up here is O, H. So for cosine, the first letter is C, and then we have A and H. And down here for tangent, we have T and then O and A. So a little acronym that a lot of people use is called SOHCAHTOA. Okay? And those are just the first letters of each one. So I have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then TOA, tangent, is opposite over adjacent. Okay, so this example down here, we're just going to label the 3 different sides. Okay, so this right here, that means that's my angle. So I'm going to go ahead and put a theta since we're using theta as our reference angle. So I need to find opposite, adjacent, and hypotenuse. So hypotenuse is easiest to start with. Remember, hypotenuse is always across from the right angle. So here's my right angle. Opposite or across from it is over here. So this will be my hypotenuse. Opposite is always across from theta. So if this is theta, the side opposite of it is over here. So this will be opposite. So that means this has to be adjacent because it's right next to theta. So if we look at the second one, this means my angle again, so I'm going to go ahead and label it theta. So if we start with hypotenuse, here's my 90 degree. If we go across from it or opposite of it, we're over here, so this would be hypotenuse. Okay, here's theta, so across or opposite of theta is this side right here, so this would be the opposite side, and this is the adjacent. Okay, and the last one, here's theta again. Here's the 90 degree angle, so opposite of the 90 degree angle is the hypotenuse. Here's theta, opposite of theta is the opposite side, and then here's the adjacent side. So make sure you understand how to label those sides. If you don't understand, this lesson is going to be very hard. Okay, so if you go to the back of your notes, we're going to find each trig ratio. Okay, so let's just look at the first 3 over here. Sine, cosine, tangent. I'm dealing with angle A. So angle A I'm going to label as theta. Okay, so let's just go ahead and ignore the numbers for now and label opposite, adjacent, hypotenuse. So here's my 90 degree angle. We know across from it is hypotenuse. Here's theta. Across from that or opposite of it is the opposite side. And then next to it's the adjacent side. So I'm not even looking at this part over here. I'm only dealing with the left side. Okay, so sine. If you go back to your trig ratio, sine is O over H, or opposite over hypotenuse. Okay, so my opposite is 8 over my hypotenuse is 17. So 8 over 17. And cosine is adjacent over hypotenuse, or A over H. So here my A is 15, and then H is 17, so 15 over 17. And the last one, tangent, is O over A. So O is equal to 8, A is equal to 15. Okay, so let's go to the right-hand side. Now we're going to go to angle B. So I'm just going to scribble through each of these because we're going to have to relabel the triangle. So angle B is right here. So this is my theta. Okay, so hypotenuse is across from the 90 degree angle, so this is still my hypotenuse. Hypotenuse will never change depending on what angle you use. So if this was theta, now my opposite is going to be over here. So that means this is my adjacent. So if I have sine of B, we know sine is O over H. So O is 15. H is 17. Okay, cosine, A over H. So A is 8. H is 17. And then tangent, O over A. So O is 15, A is 8. Okay, so make sure you just look at your angles because it's going to try to confuse you. And make sure you switch it. When you switch to another angle, you switch your opposite, adjacent, hypotenuse sides. Okay, there is an example like this on your test, so make sure you understand this one. Okay, so using a calculator to evaluate. The main thing is your mode has to be in degrees. Okay, if it's not in degrees, and I'll show you how to change it. If it's not in degrees, then you're going to get some crazy answers. Okay, so for example, when we use our calculator, let's just say we have sine of A. Okay. A is just any number. So I'm just going to plug in sine in my calculator, plug in A, and then hit enter. And that'll tell me the value for that. Okay, on the other hand, if we have sine to the -1 power, we'll say A again. Okay, so before we go over how to calculate this -1 right here, this means inverse. Anytime you are finding the inverse, this means that you are finding an angle. So if there is no inverse, you already know the angle. If it's an inverse, then you are looking for the angle. So if there is a -1, you're only going to do one thing different. You're going to start with the button second. So you're going to go second, and then sine, and then whatever number's there, and then hit enter. Okay, so no -1, just plug it straight into your calculator. If there's a -1, then you're going to go to second sine. Okay, you will need a graphing calculator, so if you do not have one, go ahead and pause the video and everybody go grab one. Okay, so we're going to evaluate these 8 problems down here. So first thing, remember I told you your calculator has to be in degrees. Sorry, I know there's a glare. So to do that, I'm going to go to mode. So if you look at your calculator, top left-hand corner is the second button. Go 1 over to mode. Okay, so now you should have this screen here. So if you scroll down, or if you look down here, the third option down, my degrees is already highlighted. Okay, so that means my calculator is in degrees. If your radians is the one that's highlighted and not your degrees, scroll down and then scroll 1 over so that's blinking over degree and hit enter. And now it will be selected, and then hit second mode and you're out. Okay, double check that you're in degrees. So go back to mode, which is the second button right after the second one. Make sure degrees is highlighted, and it is, so just do second mode to get out of there. Okay, so the ones on the left is what we're going to start with. So we have sine of 30. So there is no -1, so I'm just going to hit the sine button, okay, which is the 4th row down, second one in. So we have sine. It'll give you a parenthesis, type in 30, and hit enter. So we should get 0.5. If you did not get 0.5, then your calculator is probably still in radians, so make sure you go back and change your mode. Second one, tangent of 45. So same row, go over to tangent. My number is 45. I should get 1. Cosine of 88, select cosine. 88. Hit enter. We get 0.0349. Make sure you round to at least 2 decimal places. So you could do that, or you could do 0.03. Okay, don't just say it's 0 or 1. Make sure you round to decimals. And the last one, tangent of 60. So we have tangent 60 is 1.732. Okay, so those had no -1, so we just plugged those straight into the calculator. Okay, let's go to the other side. These have the -1, so they have the inverse. So the first one, it's sine to the -1 of a half. So I'm going to select the second button. So now you should have a little arrow that's blinking instead of just your plain cursor. And I'm going to select sine. So now my sine button that I entered should say sine of -1. Or if I don't hit the second, it doesn't have a -1. So make sure you have the -1. And then I'm going to enter 1/2. Just enter it as a divide. So do 1 divided by 2. Hit enter. We get 30. Remember, if there's a -1, it means we're solving for an angle. So I'm going to put a degrees there, because that means it's 30 degrees. Okay, so now I have tangent, and there's a -1, so we're going to do second tangent. My number is 1, and then we get 45. So this is 45 degrees. Okay, last two. Cosine inverse of 0.35, so second cosine, 0.35. Go ahead and round to 2 decimal places, so 69.51 degrees. The last one, tangent inverse of 1/4, so second tangent, 1 divided by 4, 14.04 degrees. Okay, so those should be pretty easy. You will have some of those on your test. Remember, if there is no inverse or no -1, just plug it straight in. If there is an inverse, plug in second first. All right, so now we're going to do some examples of actually solving. So solve the missing side in each of the following triangle. Okay, so they tell us this angle here is 27, so this is like my theta. So I'm going to label the triangle opposite hypotenuse and adjacent. So if we start with hypotenuse, across from the 90 degree is hypotenuse. If this is my angle, across from that is the opposite side, and then this would be the adjacent side. So I need to either use sine, cosine, or tangent to set up a trig ratio to solve for x. Okay, if we look at h, we don't have any value with h, so I'm just going to ignore this, because there's no number or no variable there. Because if we look at the O side, we have an x. If we look at the A side, we have a 10. So I'm going to use O and A. So if you go back to your trig functions we wrote down, go through which one uses O and A. So this is O and H, A and H, O and A. So I'm going to use tangent. So I'm just going to write out the ratio. We know tangent of theta is equal to O over A. Okay, so now let's fill in what we know. So we have tangent. Theta is the angle. So we know our angle is 27. O is equal to x. A is equal to 10. So tangent of 27 is equal to x over 10. Okay, so I'm going to go ahead and get x by itself first. So remember, we're dividing by 10. So to undo that, we're going to multiply both sides by 10. So over here, I have 10 times the tangent of 27. On this side, my 10's cancel, so I have x. So now that my variable is by myself, I can use my calculator. Okay, I'm just going to plug it straight in. So I'm going to have 10 times tangent 27, hit enter. So x, go ahead and round to 2 decimal places. So x is 5.09. And this would be my final answer. Okay, so let's go to the one to the right. Okay, so 62 is my angle, so that's like the theta. I'm just going to put a mark here. Let's label opposite adjacent hypotenuse. So across from the 90 degree is hypotenuse. This is my angle. Across from it is the opposite side, so this would be the adjacent side. There is no number or variable with h, so I'm going to ignore that. So I have O and A. So if I go back to my trig functions again, that's tangent. So we know tangent of theta is O over A. So theta is the angle. The angle is 62. O is equal to 12. A is equal to x. Okay, so here again we have to solve for x. So the difference between these two here, x was in the numerator here, x is in the denominator. Okay, so do not multiply by 12. If you multiply by 12, that does not get rid of your fraction. You always have to multiply by the denominator. So I still need to multiply both sides by x. So we have x times tangent of 62. So my x's cancel, and that equals 12. I still don't have my x by itself. So to get x by itself, I'm going to divide both sides by tangent of 62. So on the left-hand side, the tangents of 62 cancels. And I'm going to plug this into my calculator. So plug in 12 divided by tangent 62. You should get about 6.38. Okay, again, remember, you always multiply by the denominator, even if the variable is down there. So you're just going to have to multiply and then divide. So you'll have an extra step if your variable is in your denominator. Okay, we have two more of these. So here's our angle. Let's label opposite adjacent hypotenuse. So cross from 90-degree hypotenuse. So be opposite and adjacent. So I don't have any number with A, so I'm going to ignore that. So I'm going to use O and H. So if you go back to your trig functions, that should be sine. So we know sine of theta is O over H. So we have sine, theta is the angle. The angle is 70. O is equal to X. H is equal to 7. Okay, so we want X by itself. Again, remember you're always going to multiply by the denominator. So we have 7 times sine of 70 equals X, because those 7's cancel. X is by itself. So just plug in 7 times sine of 70, and we get 6.58 is equal to X. Okay, we're going to do one more. So here the angle is 57. Label opposite adjacent hypotenuse. Okay, again, I don't have any number with A, so I'm going to ignore A. So I have O and H again. So that's going to be sine. So theta, my angle is 57. O is equal to 10.8. H is equal to X. Okay, again, always multiply by the denominator. So I'm going to multiply both sides by X. So we have X times sine of 57 equals 10.8, because those X's cancel. So last step, we need X by itself, so divide by sine of 57. So left-hand side, we're left with X. Now plug in 10.8 divided by sine of 57. Should get about 12.88. Okay, so remember, start by labeling your triangle with opposite adjacent hypotenuse. See what two sides you have. Figure out your trig function. Set up your ratio. Always multiply by your denominator, and then just use your calculator. Okay, last two examples. Those we were finding missing sides. Now we're going to find the missing angles. Okay, so this X right here, that's an angle. I'm going to label my opposite adjacent hypotenuse sides. Okay, so I do not have A, I have O and H. So I'm going to use sine. Okay, theta is the angle. So the angle is X, so we have sine of X. O is 4, H is 5. Okay, the difference here. Remember, we are solving for an angle, so that means we are using the inverse. Anytime you're solving for an angle, you're always using inverse. So to set this up, I'm going to leave the x on the left-hand side, but I'm going to move sine to the right. If I move sine, I need to put the -1 with it. Okay, and then I'm going to keep the 4 over 5. So I keep the x. I needed to get rid of sine, so I took it to the other side, but I have to put the -1. So I have sine of -1 of 4/5. So in your calculator, plug in second sine, 4 divided by 5. And we should get 53.13 degrees because we were finding an angle. Okay, so again, solving for an angle, so I have to do the -1 and I have to use second in my calculator. Okay, last example. Here's the angle again. Label opposite adjacent hypotenuse. I don't have H, I only have O and A. So go back to your trig ratios. O and A is tangent. So theta is the angle. Our angle is X. O is equal to 8. A is equal to 12. So again, X is with the trig function. So I'm going to keep X on the left-hand side, but I need to get tangent to the right-hand side. So now I'm going to have tangent to the -1 is 8 over 12. So in your calculator, plug in second tangent, 8 over 12. Then we get 33.69 degrees. Okay, so your homework assignment for this is a worksheet. However, you need to show your sub that you completed everything on these notes before you get your worksheet. So if you skip something, then you're going to have to go back in the video and copy it down before you can get your worksheet. So your worksheet will be due on Monday. If you have questions, Ms. Cannell will go over it with you, and she will continue with this. There's a little bit more to do with the trig. So she will do a little bit more in case you had any questions or if you were a little bit confused. And make sure you guys email me if you have any questions or concerns, and I'll be back in a couple of weeks.